This is SpaceTime Series 24, Episode 133, full broadcast on the 22nd of November 2021. Coming up on SpaceTime, Russia slammed for its anti-satellite missile test, NASA's DART planetary defense mission ready for launch, and a new study looking at the fate of tectonic plates once they sink below the surface. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Russia is being condemned by nations around the world for conducting an anti-satellite missile test, which not only threatened the International Space Station and its crew, but has produced a cloud of shrapnel and debris that will remain a threat to space navigation for decades to come. At a time when scientists are searching for ways to remove the growing problem of space junk, Moscow's actions have been seen globally as highly dangerous, incredibly selfish, and totally irresponsible. The test involved a Russian PL-19 Noodle hit-to-kill direct-descent anti-satellite interceptor missile launched from the Plesetsk Cosmodrome in Russia's Far East. The missile's target was the disused Soviet Union-era Cosmos 1408 electronic and signals intelligence gathering spy satellite. The 2,200-kilogram Cosmos 1408 was launched way back in 1982, also from Plesetsk, and it was in a 487 by 461 kilometre high orbit. The missile's impact into the satellite produced at least 1,500 tangible debris fragments. That is, fragments that were easily detectable on radar. And it's fair to assume that these would have been surrounded by a glowing, bellowing cloud of smaller pieces of shrapnel, all of it flying through space at 28,000 kilometres per hour, and all of it forming a massive debris field that will persist as a threat for decades to come. In fact, just in the last few days, radars tracked 100 additional objects in the debris cloud, which now stretches from altitudes of 520 down to 440 kilometres. NASA Chief Bill Nelson says he's outraged by Moscow's irresponsible destabilising action. The United Kingdom's Defence Secretary Ben Wallace also condemned Russia's actions. And US Space Command General Jay Raymond says the test was further proof of Russia's hypocritical advocacy of outer space arms control proposals, which are really designed to restrict the capabilities of the United States, while Moscow clearly has no intention of halting its own counter-space weapons programs. As soon as NASA found out what had happened, it ordered space station crew to close all hatches to radial modules on the orbiting outpost, including the European Columbus Research Module, Japan's Kibo Science Module, the Multipurpose Logistics Module, the Bigelow Expandable Activity Module, and the Quest Joint Airlock. Hatches between the American and Russian segments of the space station were left open. But all crew aboard the ISS were ordered to their escape capsules and were ordered to remain there for at least 2 complete orbits past the region of the debris cloud. Russia's Federal Space Agency Roscosmos says it wasn't made aware of the test until after it had taken place. Of course, this isn't the first time this sort of thing's happened. Back in 2007, China was slammed by the international community after deliberately blowing up a disused 750-kilogram weather satellite in their own anti-satellite missile test. The Fengyun FY-1C weather satellite was hit at a speed of over 8 kilometres per second at an altitude of more than 865 kilometres by an SC-19 ASAT ballistic missile launched from the Xichang Satellite Launch Center. In 2019, India conducted its first ASAT test using a Praveti Mark II ballistic missile to shoot down a small target satellite. But the difference here is that satellite was placed in a low Earth orbit at an altitude of just 300 kilometres, and that's low enough for atmospheric drag to accelerate the orbital decay rate of the debris cloud produced. And the same thing happened with the United States back in 2008. They shot down the decaying National Reconnaissance Office NRL-21 spy satellite. The satellite, thought to be a lacrosse radar satellite, was out of control, and a decision was made to take it out in order to prevent it crashing to the ground in a populated area, spreading toxic hydrazine fuel, and also, let's face it, making sure that classified components aboard the spacecraft which survived re-entry weren't able to be salvaged by foreign interests. What became known as Operation Burnt Frost saw the United States fire a Standard Missile-3 from the Aegis-equipped Ticonderoga-class guided missile cruiser USS Lake Erie. The shootdown successfully took the satellite out at an altitude of 240 kilometers. Again, being so low meant atmospheric drag deorbited spacecraft debris fairly quickly. And that's the point. The Indian and American actions didn't compromise space navigation in a way that China and Russia clearly have. Current estimates suggest there are more than 200 million bits of space junk, a few centimeters or less in size, currently orbiting the Earth. One of the big fears are cascade events in which satellites, spent rocket stages or bits of space junk slam into each other, in the process creating more space junk, which then slams into other spacecraft, creating even more space debris and so on. Ultimately, the Earth could face what scientists call a Kessler Syndrome. First proposed by NASA's scientist Donald Kessler back in 1978, the Kessler Syndrome involves a runaway chain reaction of collisions, exponentially increasing the amount of debris clouds orbiting the Earth, eventually reaching a point where the distribution of debris could render space activities and the use of satellites in specific orbital ranges impractical for generations. Associate Professor Michael Brown from Monash University says while the Russian test isn't a Kessler Syndrome yet, it was nevertheless reckless and poses a threat to other spacecraft, including both the Chinese and International Space Stations.
So the Kessler Syndrome is the possibility that if you have enough debris in low Earth orbit, that debris can produce enough collisions to produce even more debris, and you have a runaway train of debris in low Earth orbit, which makes low Earth orbit unusable. We're a long way from that yet, but it is a concern going forward, and certainly over the past decade or two, various nations have been getting progressively better at cleaning up after themselves when they do launches into low Earth orbit. So, for example, when you have a lot of launches now into low Earth orbit, often the second stage is deliberately deorbited almost immediately after the launch so that there's not debris in orbit such as disused rocket stages. So, yeah, there's definitely an awareness of the issue and mitigation of that issue going on at the moment.
How close is what we're seeing today with this test to those opening scenes of the movie Gravity?
Yeah, well, look, at least we don't have to put up with Gravity's dialogue, but we're fortunately still away from that, which is a good thing, but it is a long-term concern. The amount of material that is in orbit, the amount of space junk that is in orbit has increased very rapidly over the past decade or two. And so we just can't go on that trend forever. We really need to start cleaning up low Earth orbit in the long run so that it can continue to be used productively for research, for monitoring weather, for monitoring plant growth, for all the things that, we make use of satellites every day. And so this is something that we need to be fully aware of.
Earlier this year, there was an EVA conducted outside the International Space Station, and as the astronauts were going about their duties, they looked at the Canadarm2 and they noticed a hole in one of the actuators that was caused probably by space junk. The fact that we're seeing this now, that's got to be going down a path that is uncomfortable.
Yeah, absolutely. And look, very small pieces of space junk hitting the space station and the shuttle and everything else has been part of the scene for decades now.
Yeah,
and look, even
on the windscreen of the Space Shuttle Discovery, leaving a huge crater.
Yeah, exactly. So, look, it is definitely an issue, and it's one that there needs to be a very strong focus on. So when satellites are launched, making sure as little comes off those launches as possible, that it's the satellite, it's the launcher, and not anything else, that when things are launched into space, that they don't shed paint, that the upper stages are deorbited if possible, or at least put into an orbit that's not one that's used by functioning satellites. That sort of thing really needs to be happening very consistently.
So what's going to happen to this debris cloud now? Will it disperse over time, or will these pieces slam into other bits of debris from the same explosion? How do the physics of these sorts of things work out?
So it will depend a little bit on the size of the pieces, and we'll start getting a better picture of that over the coming weeks as more and more pieces of debris are tracked by radars across the world. So the larger chunks of debris will stay in orbit for quite a long time, but there might be some smaller pieces, relatively lightweight, relatively high in drag, which will have orbits that decay relatively rapidly. So there might be some smaller chunks of debris that deorbit in 6 months to 12 months. The larger pieces will probably be up there for many years. The orbits will definitely disperse, so they're already dispersing along the original orbit of the satellite. Some of the objects in lower orbit take less time to orbit the Earth, and so they're sort of moving one way. There's stuff that's been ejected into higher orbits, which will take a longer time to orbit the Earth and disperse the other way. And then also the orbits will gradually process around the world, so sort of fill out into a cloud above the world. So, yeah, the risk will be sort of spread, and that risk will be there for quite some time.
At that particular orbital altitude, around 480 kilometres thereabouts, that's where an awful lot of satellites are.
Yeah, exactly. So, there's a lot of satellites in there. The most obvious one is that the International Space Station is in that ballpark. You have a whole lot of other satellites in there as well, the various satellite constellations that are being launched and things like that. And the orbits in question for the debris aren't necessarily all going to be nice circular orbits. They're going to be ellipses, so some are going to dip up and down above and below the original altitude of the Cosmos 1408 satellite. And so, yeah, they pose more risk than a lot more risks than the original Cosmos 1408 did. One of the issues with this latest test is that the altitude is reasonably high, so the debris, or some of the debris, is going to remain up there for quite some time. And obviously, compared to, say, anti-satellite missile tests in decades past, there's a lot more stuff up there to collide with, which presents problems as well. So if they'd shot down the satellite that was only, say, 200 kilometres above the Earth, there's a lot of drag at 200 kilometres altitude, and the debris would have come down a lot quicker. But there's going to be debris from Cosmos 1408 in orbit, many years from now.
Yeah, that was the point of both the American and the Indian tests, wasn't it? That they waited till it was closer to the surface than either the Chinese or the Russian tests.
Yeah, and you'd hope that was somewhat by design to sort of keep low Earth orbit reasonably free of debris. Although in the case of the American spy satellite, it might have been a pragmatic decision to destroy the satellite so that recoverable pieces could not make it to Earth. And so technology that they didn't want getting into certain hands was not on the surface of the Earth.
Is there anything significant in the timing of this particular Russian test?
I haven't seen anyone make any explicit connection between this test and sort of broader geopolitical goals, although people make reading Russian politics a career, so I'm not sure I necessarily can provide greater insights than those particular people. So I don't see necessarily any significance in this particular test. I guess it is part of a broader pattern of various spacefaring nations testing anti-satellite missiles, as you've mentioned before. Done it, the Chinese have done it, the Indians have done it. It's messier than previous tests, which is unfortunate. And I think, unfortunately, this will continue, particularly when there's not some treaty that's preventing these tests.
That's Associate Professor Michael Brown from Monash University. And this is SpaceTime. Still to come, NASA's DART planetary defense mission ready to launch, and a new study claims Earth's tectonic plates remain intact, though weakened, as they sink down into the planet's mantle. All that and more still to come on SpaceTime. All systems are go for this week's launch of NASA's DART planetary defense mission. DART is part of a joint NASA European Space Agency mission to slam an impactor into a pyramid-sized moon orbiting a mountain-sized near-Earth asteroid. The primary asteroid, known as Didymos, is some 780 metres wide. It's orbited at a distance of about 1.2 kilometres by a small 160 metre wide moon called Didymoon, which will be the target of the impactor. Didymos will come within 11 million kilometres of Earth next year, comparatively close by astronomical standards. And this provides both ESA and NASA with an opportunity for a planetary defence experiment. The DART spacecraft will launch aboard a SpaceX Falcon 9 rocket from the Vandenberg Space Force Base in California, with the launch window opening on November the 24th. After more than a year of cruise, it'll intercept the Didymos moonlet in late September 2022. And NASA will slam the DART impactor into Didymoon in October 2022 at some 24,000 kilometers an hour in order to see what happens. Didymoon's orbital velocity is expected to be shifted by around half a millimeter per second by the impact, changing its rotational period enough to be measured roughly with Earth-based telescopes. DART's collision should leave a 20-meter wide crater on Didymoon's surface. And mapping the shape and dimensions of this crater will provide unique information to design future asteroid deflection missions. In addition, it will shed light on the asteroid's surface properties and internal structure. Scientists want to know if Didymoon is a monolithic mass or a rubble pile loosely held together by gravity. Is it composed of large or tiny grains? And is its subsurface composition the same as that on its surface? And that's where the European Space Agency's contribution comes in. They'll launch their own spacecraft called Hera. Hera is named after the Greek goddess of marriage and is slated to launch in 2024, arriving at the Didymos system in 2026. It will investigate the aftermath of the impact of NASA's DART spacecraft, undertaking detailed follow-up observations surveying the impact site. This joint NASA-ESA mission will provide astronomers with data on whether a kinetic deflection technique could really work, shifting an asteroid off a trajectory to target the Earth. Hera will also gather crucial scientific data on asteroids as a whole, by carefully studying both the exterior and interior properties of both bodies in the system. Hera will map Didymoon's surface down to a resolution of just a few meters, and the area around the DART impact crater down to less than 10 centimeters in resolution through a series of close flybys. It will also map much of the surface of the primary Didymos asteroid, providing crucial scientific data from two asteroids in a single mission. Because Didymoon is in such a close orbit around Didymos, the change in its orbit will be easy to observe from the ground. But a full picture of the collision and resulting momentum transfer will only really become possible once Hera maps Didymoon to a high level of accuracy, which will be necessary for scientists to model the tiny two-body system. Hera will also deploy two briefcase-sized 6-unit CubeSats to perform the first ever multi-point measurements of an asteroid pair. The first CubeSat, called the Asteroid Prospection Explorer or APEX, will perform detailed spectral measurements of both asteroid surfaces, measuring the sunlight reflected by Didymos and breaking down its various colours to discover how these asteroids have interacted with the space environment. The other CubeSat, called Juventus, will measure the gravity field as well as the internal structure of Didymoon and eventually land on the tiny moon. It'll line up with Hera to perform satellite-to-satellite radio science experiments and carry out a low-frequency radar survey of the asteroid to explore its interior. This is SpaceTime. Still to come. A new study claims Earth's tectonic plates remain intact, although weakened, as they sink down through the planet's mantle. And later in the science report, increased greenhouse gas levels have been confirmed as the main drivers of global warming. All that and more still to come on SpaceTime. A new study claims Earth's tectonic plates remain intact though weakened as they sink down through the planet's mantle. Earth's surface is covered by a jumble of jostling tectonic plates, with new ones emerging from mid-ocean ridges as older ones are pulled under its subduction zones. The ongoing cycle keeps continents in motion and drives life on the planet. But what happens when a tectonic plate reaches a subduction zone and then slowly disappears into the planet's interior? It's a question which has long puzzled scientists because conventional wisdom suggests that sinking tectonic plates must remain intact in order to keep pulling on the portion of the plate behind it. But according to the geophysical evidence, it seems they're actually destroyed. Now, a new study reported in the journal Nature may have reconciled the two stories. It seems plates are significantly weakened as they sink down, but not so much that they break apart entirely. The findings are based on computer analysis, with scientists putting tectonic plates through a computer-generated gauntlet of destructive geologic forces. The new model shows that as a tectonic plate enters the mantle, it bends abruptly downwards, cracking its cold, brittle back. At the same time, the bending changes the fine-grained structure of the rock along its underbelly, leaving it weakened. Now, combined, the stresses pitch the rock along its weak points, leaving it mostly intact but segmented, sort of like a geological slinky. This means the plate continues to be pulled down despite becoming folded and distorted. The new predictions match observations from Japan. Studies of the region where the Pacific tectonic plate dives or subducts under Japan have turned up large cracks where the plate bends downwards, and they have shown signs of weaker material underneath. And deep seismic imaging has also revealed tectonic shapes in the Earth's mantle under Japan that appear to closely match the model. One of the study's authors, Thorsten Becker from the University of Texas, says while the study doesn't necessarily close the book on what happens to subducting plates, it does provide compelling evidence to explain several important geological processes. Until now, geophysicists have lacked a comprehensive explanation of exactly how tectonic plates bend without breaking. Things got interesting when the researchers ran their simulations with a hotter interior, similar to that of the early Earth. In these simulations, the tectonic segments made it only a few kilometres into the mantle before breaking off. And that means that subduction would have occurred intermittently, raising the possibility that modern plate tectonics really only began within the past billion years or so. A fascinating prospect. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study reconstructing the past 24,000 years of Earth's climate since the last ice age has confirmed that increasing greenhouse gas levels and a retreat of planetary ice sheets are the main drivers of global warming. The findings, reported in the journal Nature, also showed that the magnitude and rate of warming over the past 150 years far surpasses the magnitude and rate of change over the previous 24,000 years. The authors reconstructed past temperatures using two separate independent methods. The first involved chemical signatures of marine sediments based on how temperature affects chemical reactions. The other was based on computer-simulated climate models. The research by the University of Arizona shows that the speed of human-induced global warming is far greater than anything seen over the previous 24,000 years. Geologists have discovered a new never-before-seen mineral inside a diamond hauled up from deep below the Earth's surface. The new mineral has been named Dave Mayoite after the geophysicist Ho Kwang Dave Mayo. The mineral consists of little more than a series of tiny specks inside the diamond, but it represents the first example of a high-pressure calcium silicate perovskite. Another form of the mineral known as wollastonite is common, but it lacks the high-pressure, high-temperature crystalline structure generated by formation deep in the Earth's mantle. Dave Mayoite has long been predicted but not previously found because it breaks down into other minerals as pressures and temperatures decrease as it moves towards the surface. The mineral was found in a diamond from Botswana, which had formed in the mantle around 660 kilometres below the surface. Paleontologists have identified a new species of dinosaur from Greenland. The new pletosauroid sauropodomorph dinosaurs have been named Izzy-Sneak. The discoveries, reported in the journal Diversity, are based on two fossilised skulls dating back some 214 million years to the late Triassic in what is now the Jamesonland Peninsula of eastern Greenland. This medium-sized long-necked dinosaur was a predecessor to the sauropods, which would grow to become the largest land animals that ever lived.
Overture, curtain lights, this is it. rehearsing and nursing a part. We know every part by heart. Oh, the curtain lights. This is it. We'll hit the heights. And oh, what heights we'll hit. On with the show. This is it.
The glittering highlight of the Australian Skeptical calendar is the annual Skepticon conference, which this year was held virtually thanks to the ongoing COVID-19 pandemic. The star-studded gala affair is a beacon for some of the leading lights of high society and a magnet for the rich and powerful. Of course, all eyes are on the highlight of the evening, the highly coveted Bent Spoon Award. It's presented annually to the perpetrator of the most preposterous piece of paranormal or pseudoscientific piffle. I understand the award is rumoured to have been fashioned out of a piece of gopher wood actually salvaged from Noah's Ark. Upon its sturdy base is affixed a spoon, rumoured to have been used at the Last Supper. This spoon was allegedly bent by old magic energies unknown to science, and then turned into gold by an ancient Atlantean process of alchemy known only to the mystical artisans of the time. Although awarded annually since 1982, only one copy of the trophy exists, as anyone wishing to acquire it must firstly remove it from its keepers by paranormal means. And surprisingly, no winner has yet overcome this obstacle. Past winners of this elegant trophy have included the ABC, that's the Australian Broadcasting Corporation, for demonstrating new lows in journalistic standards with their motto, "Never let the facts get in the way of a good story." Who can forget when the University of Wollongong won the award for proving once and for all that you don't need to be smart, or right, or even scientifically accurate to get a doctorate? Then there was the famous Adelaide psychic Anne Dankbar. She won the Bent Spoon for her discovery of the Colossus of Rhodes, which created something of a media frenzy. It was until it was later shown to be nothing more than modern builder's rubble. The ABC won the award for their television show Second Opinion, which promoted so much unscientific quackery they really should have got a few more opinions. Southern Cross University won the award for offering a degree in a course in naturopathy. The CSIRO's chief Larry Marshall won the award for his support of water divining. The ABC won the award for spending taxpayer money on psychic investigators. Racing driver Peter Brock, may he rest in peace, won the award for his highly touted energy polarizer. Unfortunately, it generated more heat in the motoring media than what it did energy in his racing car. The SBS won the award for their TV program Medicine or Myth, which promoted alternative medical treatments as if they had any scientific credibility, as opposed to being, well, really nothing more than the occasional placebo effect. The Melbourne Metropolitan Board of Works won the award for hiring a US psychic archaeologist. Yes, apparently such people do exist. The archaeologist was meant to detect non-existent electromagnetic photo fields. Oh, and did we mention the taxpayer-funded ABC? Well, they won the award for their show New Inventors, which seriously considered the pseudoscientific benefits of the anti-bio water conditioning system, which probably should have been filtered through the kidneys a few more times. Still, that's what you get for spending $1 billion of taxpayers' money every year. And now, with the details of this year's winner and wearing his best formal attire for the occasion, we're joined once again by Tim Mendham from Australian Skeptics.
The Bent Spoon, bit of background, it's been going since 1980, whatever, mid-80s anyway, for about 35 years. So we've had a lot of interesting candidates. The spoon goes to the perpetrator of the most preposterous piece of pseudo-scientific or paranormal piffle. We had a number of candidates, dishonourable mentions, if you like. The ABC
Of course.
got a mention for a program on biodynamic agriculture, which is the thing where you plant fertilizer.
In cows' horns and things like that?
Cows' horns and that sort of stuff, and by the moon and by astrology and that sort of thing.
I must
that was
admit,
a bit
when I
weird.
was working for ABC Science, we didn't cover anything like that.
Anyway, that's one candidate. The Channel 7 ran a story about UFOs.
And
by,
they're doing a follow-up,
journal-
it looks like.
Oh, yeah. Probably Ross Coulthard again.
It is indeed, yes.
They just recycled the same old news, despite the cases being thoroughly debunked, etc. And then Australian Geographic, that journal of note, founded by our patron, Dick Smith, unfortunately, ran their own story on UFOs, written by the same person who did the TV show on Channel 7.
Oh, really?
So that was disappointing, to say the least.
That's really sad because that sort of thing detracts from the credibility credibility of the publisher, doesn't it?
Absolutely, yeah. Dick Smith sold the magazine a long time ago, but he still feels a sort of proprietorial closeness to it, and he was sort of not pleased, especially, it's a factual publication, science publication, science-based.
Exactly.
It's popular, but it's science-based.
It's been respected.
Yeah, so that was very disappointing. Don't know how that one got in. What else did we have? With the usual sort of panoply of alternative medicine people and that sort of stuff, especially these days with COVID cures and all sorts of shonky stuff. But the winner, the Ben Spoon winner, drum roll, Craig Kelly, MP.
Well, what'd you give it to Craig?
Well, for a man who's very shouty, he's shouting so much misinformation about COVID, about vaccines, about 5G, about you name it, every conspiracy theory going, dodgy cures, dodgy treatments. He was a hands-down winner, I think, this year. He was a unanimous choice, really. So Craig can be very happy about that, but all the skeptics think he deserves a Ben Spoon.
He'll say it's all political, don't you? And he'll dismiss the whole thing as being just a political conspiracy by the left wing.
He could do that if he likes. But, we always awarded on the basis of science and not politics, and his science was less than impressive.
Was there a close seconder?
No. I mean, the rest of them were pretty sort of minor, and they were specific things, like one-off, like the Australian Geographic and that sort of stuff. Channel 7, if they're going to run another story, great. But the Craig Kelly's just been doing it all year and last year.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.